Hi, in this tutorial I'm going to do a brief discussion of how to do the uh, another discussion about how to demonstrate that the number of hidden units in a neural network is a regularization parameter. And so in the previous tutorial I showed you how to do this kind of parallel for loop, this future lapply call over the number of hidden units in the neural network. We consider from 2 to 1024 hidden units. For each one, what we did is we constructed this model with one hidden layer with that number of units, and then what we did is we compiled the model, and here what I did since last time, I made a change here in the optimizer function. Before we had optimizer equals SGD for stochastic gradient descent, and here I'm using another version of stochastic gradient descent called Atom with a learning rate of 0.01. That's the same thing as a step size. And what I'm doing is I'm doing 100 epochs for each one of these different models and computing the validation error with respect to a fixed validation set. And here at the end of the for loop, I return this data table that has all of these metrics, and then I combine them all, and the results I plotted look like this. The idea is that here in the different panels, going from left to right, at top to bottom, we have the different numbers of hidden units in the neural network. So here it starts out with 2 hidden units, and it goes all the way up to 1024 down here. And so in each case, what we see is that the subtrain error goes down consistently. And so here I'm drawing a point to highlight the minimum of each curve. And so we see the minimum of the subtrain set is pretty much always at the maximum number of epochs, which is what we should see, up to a slight variations because of this good stochastic nature of the gradient descent algorithm. And with the validation set, what we see is the common trend, which is it's going down and then it's going back up again, right? So with only 2 hidden units, we don't see a lot of overfitting, right? So we don't see the curve going back up quite a lot. But the more hidden units you have, the more powerful the model is, and so the more potential you have for overfitting. So as you can see, as you increase the number of hidden units, you can get really big gaps between the subtrain and the validation error. Whereas with the smaller number of hidden units, the model capacity and the ability to overfit is reduced, and so you don't have as big of a gap between subtrain and validation error. So this suggests that this is a regularization parameter, the number of hidden units. And so what I'm going to do now is I'm going to plot this minimum value every time, right? So here I drew a dot to emphasize what is the minimum error, so the minimum loss with respect to the subtraining validation error. And so what I'm going to do is I'm going to now plot those numbers just by themselves. So here now we have a plot of the loss as a function of the number of hidden units. And so again, what we see is that with respect to the subtrain set, we see that the loss goes down as we increase the number of hidden units. So we're better able to fit the data as we get more hidden units in the neural network. However, when we look at the validation loss, we see that it goes down up to a certain point here, like around 10 or 20 hidden units. I guess that's probably 16. And then after that, it starts to go up again. And so what this says is that more hidden units is not necessarily better, right? Our goal is to get a model that generalizes well to unseen test data. So we need to think about regularizing the model by limiting the number of hidden units. And so we need to do some analysis like this to help us select what the number of hidden units should be, because we don't know, for every data set, this is going to be a different number. So for this particular data set, the spam data set, it seems like this is about the right number of hidden units. But for other data sets, you might have larger numbers. Okay, thanks for listening.